So the purpose for stereo is try to find the depth. The depth is information, or the z, x, y, z, the z information. So stereo is based on the left side command and right side command. With both sides, you will see from the left side, you will see more information on left, but you lose information on the right side. In the other side, to say in the right side image, you'll see more information on the right side. So if both images we overlap together, so overlap region probably is only overlap region probably is this one here, this one, this part here. This region is overlap. This region, the same overlap region. So you lose some information. That should be fine. So that's meaning if you baseline of the areas is too wider. Wider means the baseline wider you can see far away, but you will lose some overlap region. So after that one, the purpose is suppose we call left side image is a reference image. And your purpose is for each pixel, like this one, you try to find the corresponding pixel. The same, each pixel, like this pixel, you try to find the corresponding pixel. So in the other words, you said for the left side image, you go back, you find a corresponding point. The right side image will be in your left hand side. 你从左边去找右边这个相对过来，你的右边的 pixel 一定出现在你的左边，这样只要往这方向找就好。So the other is how can we find a corresponding pixel? It's better way is we reduce the 2D search to 1D is 1D search. So we use the epipolar line to use this information. So each line, epipolar line on the left side image, you'll find the corresponding line on the right side image. And OpenCV provide you those kind of information. In order to get the epipolar line, we will introduce essential matrix. Essential matrix is 3D to 3D. What we see is 2D to 2D. So we need to use fundamental matrix. So this matrix. And this matrix meaning either way, any left side image, left side image pixel. Based on the fundamental matrix, you can find corresponding right side pixel. And the fundamental matrix, this one, includes the 2D left side image, and we project to 3D. That's intrinsic parameters, so we project to 3D. And based on the E is the essential matrix, include rotation and translation. It's cross product, but we change it to be the inner product format. After RT, because 3D to 3D is a rotation translation. 2D to 2D also rotation translation. 3D and the relationship between 3D and 2D is intrinsic parameters. And this is extrinsic parameters. So after you transfer to the 3D, and we will project, inverse the transpose, project to here. You said based on the intrinsic parameters of 3D project to 2D, so match to the right hand side. So either way, you can from right to left, left to right. But this is theory. But in reality, it's impossible to find corresponding point. But you can find from each point you can find based on fundamental matrix, you can find corresponding norm. So OpenCV to find this kind of information. To prove the corresponding line with this one. This one. I don't explain too much because this a bit complicated. And then many different methods talk about how to find corresponding line. So that's basically that's the stereo. To reduce the computation， 就是我们为了减少这种复杂 stereo 的复杂度 ，stereo 没有什么复杂，是最主要是它有4个参数比较复杂，都是变数嘛，所以比较蛮麻烦。那我们刚刚讲那么多的例子的 purpose 的 if this。So in reality, suppose I want to talk about the next step is that rectification. Rectification. What's a rectification? Actually, the purpose is try to align two image plane. 想把两个 image plane 把 align together and parallel to this baseline. So the way you will do it, no matter how you put an image, so actually put a camera, and based on the image plane of the camera, and you can project this virtual plane. The other side project to the virtual plane, and this we assume both virtual plane will parallel to the baseline. 就是说，你不管你设计怎么放，实际上希望把它 project 到同的 plane 变成平行。So stereo, the purpose we try to, and no matter in 3D, no matter what kind of we call pose or poses, how the camera poses meaning how you put the camera in 3D. When you read the paper, they say the camera has a pose. What's the pose mean? Pose meaning the camera in 3D, any the position, 3D position of the camera. Based on the pose of the camera, and then we try to project the image plane of the camera back to this virtual plane, and we hope two camera levels, the plane will parallel to the baseline. If it's parallel, that will be easy to find corresponding point. So in order to be easy to find the corresponding point, we need to do camera, image rectification. That's also the rectification 校正。Now rectification include rotation and translation. But if this case will become, we have three cases for the camera. This is page 47. We back to here, page 47. So one camera is two cameras are not parallel to each other. Is one case. Second case is one here parallel to the what you want to see, and the other is a little bit angle. So in both cases, we use a rectification to project to this kind of case. So three cases for stereo position, camera position. The first one, the second one, we try to do the stereo, we will use rectification, align two image plane to parallel to the baseline. 把它变成这样虚拟的，把它就变整了。那这样的话 ，you will reduce. You don't have a location information, but the location information here is for rectification. So after two cameras, you are parallel to each other, and the final is the alignment, just vertical direction alignment. 最后你把两个做平行，现在就是 translation 嘛，就上下，那就比较容易的啊，就一条线对一条线这样子。 So that's in reality, we do this. We back to the page 69. Based on the coordinates of two camera, we can find accuracy parameters between two 3D camera coordinates， 就可以找得到，你校正就好了，用校正板校正，就可以找到两颗摄影机之间的 RT，use the calibration board, and you can find the accuracy parameters between two camera, and then based on the rotation, you will project back to here. And that's it. In the OpenCV, I forget page, chapter 12 or chapter 11, they talk about this one. I show you. I already give you the because in this class I did not teach you OpenCV, but in undergraduate class I teach you OpenCV, include this one. For the book. And for the homework, we already for each question we already give you the page number of OpenCV. So you just check those pages and you'll find the answer or even know the example. Here, responding to this one. In chapter 12, chapter 11 talk about how do you do the camera calibration. So for your homework, we come here. For the first homework, put all together here, this one. So the first homework, the question one, put the answers here, putting calibration all together. This one example. So the example is here. So your first the question one, the homework one, your answer is here. 出 homework 不是要去故意去刁难你，让你什么成绩怎样？出 homework 主要目的是希望你。我们上课中间，我们是希望举实际的例子，让你去实做，这样子。那助教都会帮你把那个哪一页的那个答案，就是相关的资讯会跟你讲。那你就去读一下，像我说第一个 homework 答案就在这边，这个，所以你可以读这个例子。So the solution is here. 你自己再看一下这个，你就是自己看。那 for OpenCV, they have a good lecture on chapter 11, chapter 12. Other lectures just OK. 其他的 lecture 他没有讲的，就版面不是排的很好。我大学部那边会讲，所以 chapter 11 talk about camera model and camera care。怎么跟我的一样讲？因为我讲义是20年前就编好了。有比他还早，因为大家都大概都，这个领域的就是这样训练的，所以这个11章在这边。那12章 ，Today we talk about stereoism, chapter 12. And chapter 12, they are very good on stereo here. And they talk about talk about essential matrix、fundamental matrix 在这里。Stereo calibration，然后 rectification 在这边。What's the advantage of open CPU? They are more practical. They do things more practical. Open CPU 好处是它都是举实际例子，那跟我们在 CNU 学的方式都一样，有时候是举实际例子来讲。因为当然我以前在匹兹堡的时候是比较偏理论的学校，美国大学每个学校都有它的特色。匹兹堡大学是理论比较重视理论，那 CNU 那边是理论照样重视的，但是它是从实际来解决问题，所以两边的研究方式不一样。So rectification they talk about here， 所以这个你可以去参考一下。那这边市场讲的这本书这11章跟12章讲的啊，然后那个图画的内容讲的不错，在内容讲的，所以你自己再慢慢看一下，是最后一个式子，在page 435，是最后第三页式子，他讲得很清楚。所以我们都有讲 ，is from 3D to 2D，and then we from 2D drop to 3D。这你是在看，就是我们三个都有讲，那这边也都有讲，这样子。我是希望你配合看啊。大学部的课一定要找课本，所以大学部我的原则，大学部尽量有课本，那所以选择这一本书。但研究所不是有课本，研究所理论上是要教最新的知识，所以研究所当然应当是以 paper 为主。但是你们有些基本不懂的，应当要努力去读那基本的，是这样。但是我会跟你讲大概在哪边啊？刚好这一本书啊都有提供了。这边都这是我讲义都有，对，大家自己看一下。好，这就两篇自己配合看。那研究所不要一本书从头看到尾，你很努力把一本书看到尾，不是研究所读书方式不是这样子。研究所的读书方式是，你遇到问题，要针对问题，把这问题的部分解决掉。所以你的方式有可能，你读书可能是这本书只看其中某一个 chapter 这样子。For the graduate student, you cannot just study the entire book. That's not the right way. You just find the problems, try to solve problems, and then the problem probably just one section of the book. 那怎么办？那么多书怎么办？没有钱买那么多书。台湾不准盗版，美国有盗版，在美国读书的时候有盗版，这样子。好，再图片，美国学生更可怜啊，贷款不是贷，很多人贷款。So this is some result, stereo, and this ground truth. This ground truth， 这不是做出来这个是 ground truth， 不是 stereo。这你自己在这边讲。The other thing is that the other important thing is that what's the Windows window size? Actually, window size is similar to your filter size. So if your filter size or Windows make you have to find corresponding point. If your window size 3x3 is 3x3, from left to right, then you find your results is more in details. 你发现比较 details, but it's piece by piece. So it exists many more. That's the book. So the same as your filter. If you do small windows, you have more details. Actually, you will have more noise, 和杂讯。 因为你会把小地方都放大，讯号都放大。If you have a big window, it's 20 by 20, you'll find you lose the detailed information. It's not global. You have less details, but you also have less noise. Once this noise becomes, it's more smooth. So the noise will reduce by the neighborhood texture. When Windows is bigger, you consider the wider region. So your noises will reduce because they were reduced by the neighborhood textures. 这样才好一些。This is a similarity matrix meaning similarity measure, and matrix is some method. So we talk about it so many times. This is some absolute difference. So no one. Some of square difference is correlation. There's no one that's there's no one as cross. And check it by yourself. Remember the denominator term, the full term is a for the normal. 后面你就自己看后面像都旧了，删掉你自己去看。And this is the page 997 and 1998. This is the 97, but actually 97 is about the steps for the camera calibration, but for the detail should be 98. So 98, page 98. This is the basic stereo process. We try to find corresponding point. We try to calibrate, and we find a disparity. And there's the important one we call left-right check. What's the left-right check is the meaning? Because if from the left image check the right image, find a corresponding point on the right-hand side image. But maybe because try to find corresponding point, so even though some points you cannot find, some points missing because occluded, you still need to find one. So that's the error. That's meaning if you left to right do one kind of try to find disparity map, right to left to find the other disparity map, you try to find a consistent. 所以你 left right check 很重要，但是你要花一倍时间在做 left right check， 因为你把找一个 disparity map 只要 left to right， 你要找第二个 disparity map 是 right to left。那为什么这样做？是为了两张要做它的一致性。为什么？因为那个 stereo 最怕就是 occlusion。Stereo will discount situation. Occlusion situation we call half occluding. It's meaning in left side image of this object. Left side, you can see here, but you cannot see this one. In right side image, you can see this one, but you cannot see the other side. So that's meaning in image here, this part, some points cannot find corresponding point on the right side. But because it is a matrix, so you must find one result, but actually the results are incorrect. So what can you do? So you should do left-right check. Also because we don't use NCC take time. But usually when we do a stereo, we use SAD, sum absolute difference, because it is faster. But SAD has no normalization. So you can say, okay, if the matrix result is this thing, suppose 0.5, I ignore it. That's NCC. NCC normally to confidence value between 0 and 1. So you say, okay, it's a NCC value, similarity value less than 0.5, 0.5. You say that's not good. Oh, that's correct. But for SAD, is from 0 is the matrix to infinity. So you don't know the solution. But it's fast. So how can we solve a problem? They do the left right check. Okay, so that's it for the stereo. For next one today, we want to finish the SIFT.